Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 6 of lesson number 10, Gravitation. So now as we are on to part 6, like we will be requiring more three parts I guess to complete this lesson. But like as we have moved on already to part 6, we have studied so many aspects, so many points with respect to gravitation, right? So I just want each one of you to keep on revising each and everything that we are studying, because I don't want you all to sit and do that thing. Okay. Again, after like you are watching the video doing so much of hard work, and after that you are again like sitting with the same lesson doesn't make any sense, right? So you have to make sure that whatever we are studying, you're doing it properly. Okay. So like we will be discussing on this, uh like whatever we are discussing, make sure you keep on revising them and you are like making the concepts clear during the session itself, because that is what is going to save your time. And I also make sure that you take proper notes, you understand it properly. If you have seen the whole session, you might be knowing that I give you like time to take your notes. I even give you to revise each and everything twice. Once from your notes that you have written, and once from like showing you all the screen. Okay. So like this has all been developed and cultured as such that you're not spending your time like after watching the video. You don't have to spend any time. Even like we will be discussing the exercise, at that time you will be like explaining the answer in your own words. You have to be confident, like that much confident I want like all my students should have. Okay. So now, if I tell you to write a brief note on gravitation or about Sir Isaac Newton or about universal law, you should be able to do that. Or even if I provide you with an like numerical to solve by putting the formula, you should be able to do that as well. This is what my expectations are, and I hope like everyone are on the same pace. As and when we are learning it, you're revising it, and you know each and every concept in detail. Okay. So before I proceed with this part, I want each one of you to please revise the notes that you have taken till now, so that you are getting very much clear with the concepts. Okay. I hope every one of you are revising it. So I hope every one of you have started revising it and now you know the concepts in detail as well. So we have started the lesson by discussing more about gravitation, right? So I just want each one of you to please go through it quickly. I hope every one of you are going through this slide. See over here the idea of gravitation has been explained, and now I hope that every one of you will be able to write it on in your own words as well, right? Like we don't have to think sitting on what to write on gravitation. That is what I am expecting from you now. Okay? After this, we discussed on this activity 10.1, where we were actually observing how the stone was moving in a circular path, right? And that too was with respect to like it was moving with constant magnitude, right? So we have even discussed on it in the further part. I just want you all to please go through this activity. Then we discussed on the universal law of gravitation, which we like even came up with the concept as F is equal to G, that is gravitational constant, capital M, okay, and then we had small m. Now capital M is the mass of object A and small m is the mass of object B, right? So that is how it becomes directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay. I hope you all are going through the slide because this is also very important now. Then we derive the formula, that is F is equal to G, that is gravitational constant, mass of the products, that is mass of product object A and object B, upon D square is the distance square that we have, right? I hope like you will be able to elaborate it now. Now this is very important, as I tell you in every part that you can get a direct question on it. So make sure you all go through it. Okay. After this, we discussed on about Sir Isaac Newton, the discoveries and invention that he had given, right? So I just want each one of you to please go through the slide as well. Over here we have like the more work and discoveries of you can say Newton that has been given. So I want each one of you to please go through it as well. Then we discussed on this example and I want each one of you to please go through it as well. I hope every one of you are going through it. Then we discussed on the importance of the universal law of gravitation. So I just want you all to please go through it. Then we discussed on free fall with an activity. So the activity has been given on this slide, and on the next slide we have the whole explanation for this activity that has been given, right? So after this activity, here we have the explanation for free fall. Like if you take any object and throw it upward, the object is like somehow again going to drop down, right? So that is what free fall is. Okay. After this, like here we derived the acceleration due to gravity, right? So I just want each one of you to please go through it as well. So I hope you all have understood how to calculate this, right? After this, we even discussed on like how to calculate the value of g, that is acceleration due to gravity. So I want you all to go through this as well. Then we discussed on the motion of object under the influence of gravitational force of the earth. So I just want each one of you to please go through it quickly. So here we have all the three formulas or equation, you can say, which have been given. I just want each one of you to please go through it. I hope every one of you are aware of the equation now. Then we discussed on this example as well, where we calculated the speed, the average speed, and then at the end we discussed on the distance traveled as well, right? So I just want each one of you to please go through it as well. After this, we discussed on one more example that we have over here. So I want you all to please go through it. I hope every one of you are going through this, because over here we have used all the three equations, or all the like two equations we have used over here, right? So please go through it, everyone. Then we discussed on mass and weight in short, right? So I just want each one of you to please go through it. I hope every one of you are going through it. After this, we discussed on the concept of weight. So I just want you all to please go through it quickly as well. After this, like, we will be discussing on the weight of an object on moon. But before that, please make sure you are like clear with the concept of, with earlier concept as well. I hope you all are going through the formulas that have been given for force. Then now we have to discuss on weight of an object on moon. Now what do you think, like if you go on moon, what will be your weight? So we will be studying on that, like studying that itself over here. See, we have learned that weight of an object, weight of an object on earth is the force with which the earth attracts the object, right? So in the same way, the weight of an object on the moon is the force with which the moon attracts the object. Now on earth, whatever weight of the object is there on the earth, it's like the force with which the earth is attracting the object, right? Same way, when you go on moon, whatever like force the moon applies on the object, that becomes the weight of that object on moon. So sorry. Okay, so the mass of the moon is less than that of the earth. Okay, earth has more mass as compared to moon, so the mass of moon is less and earth has more mass. So due to this, the moon exerts lesser force of attraction on object. Okay, why there is lesser force of attraction on object on moon? Because the mass of moon is less as compared to that of earth, and that is the reason that moon exerts lesser force of attraction on object. Okay, so we are going to see that through this explanation that has been provided. See, let the mass of an object be m, small m. Let its weight on the moon be Wm. Now W is the weight and m is the moon. So weight of moon is Wm, and let the mass of the moon be mm. Mass of moon. So it's mm. And its radius be radius of moon. So by applying the universal law of gravitation, the weight of the object on the moon will be, weight of moon is equal to gravitational constant, mass of moon into m is mass of object upon radius of the moon square. Okay, it's like, it's the same law. Then let the weight of the same object on the earth be We, weight of the earth. So We, and the mass of the earth is capital M and its radius is R. So weight on earth is equal to gravitational constant, M is the mass of earth, right? Small m is the mass of the object upon radius square. So from both the equations we get that We is equal to G capital M into small m upon R square. And when we substitute the values, okay, like here in the table the values are been given, so from there we have to substitute the value of the mass and the radius, and we will come up with a like value as 0.165. So weight of the object on the moon divided by weight of the object on the earth is equal to 1 by 6. Okay, so weight of the object on moon is equal to 1 divided by 6 into its weight on the earth. Got it? So this is the formula that we will be using. So it is going to be 1 by 6 of the weight on the earth. Okay. I hope every one of you are going through it. I hope every one of you are writing it. I hope you all are done writing it. Like I want you all to be writing the collections that has been given. Okay. Uh, Means all the steps. Now here they have written some of the other points in between, right? So I want you all to make sure you're writing it stepwise and you're even understanding it, and you have to do it right now itself, because when you do it now it will become easier for you to understand it properly. Okay. You even need to mention the mass of the earth and moon that has been given in the table, because you are using that itself in the calculation part as well, right? Now we have an example to discuss over here. See, mass of an object is 10 kg. What is its weight on the earth? So mass is, that is m is equal to 10 kg. Now acceleration due to gravity, we know that is equal to 9.8 meter per second square, right? And then just now we discussed on the formula for calculating the weight, that is equal to m into g. So mass is 10, g we know acceleration due to gravity is 9.8. So when you calculate it, you'll get the weight as 98 Newton. Now if you remember, while we were studying weight, we discussed on that the unit is going to remain the same, right, as force. So that is why we write the unit as Newton, that is N. So thus the weight of the object is 98 Newton. Okay. After this, we have again one example. See, an object weighs 10 Newton when measured on the surface of the earth. What would be its weight when measured on the surface of moon? Okay, so we know that the weight of the object on moon is equal to 1 divided by 6, 1/6 of the weight on the earth, right? So we will be like writing the formula over here as weight of like moon is equal to weight of earth divided by 6. So we know that weight of the object on earth is 10 divided by 6, and you get the answer as 10 divided by 6 Newton. And when you divide this 10 by 6, you get the answer as 1.67 Newton. So like if you get this type of question, this is going to be very much easier for you. Okay. After this, the next thing that we have to discuss is thrust and pressure, which I'm going to start in the next part, not today. Okay, but I hope that you are clear with this concepts of like what will be the weight of an object on moon. So it's going to be like 1/6 of the weight of the earth, and we saw two different examples how to calculate the weight, right? So after this, now we will be discussing on thrust and pressure in the next class, where we will be discussing it with two different you can say situations that have been given. So we'll be using that, and we will be like studying thrust and pressure in detail. Then we again have an example to understand it properly, and then after that we will be discussing on pressure in fluids, buoyancy, then an activity 10.4, and then we have another thing to discuss, that why objects float or sink when placed on the surface of water. Okay, then we have this activity 10.6, and then we have Archimedes principle to discuss that in detail. And after Archimedes principle, like we will be discussing on the last concept, that is relative density. Okay, so we'll be discussing on relative density as well through an example, and then we have the summary discussion for the same. So we'll be doing this much, and then we have 22 exercise questions that we will be discussing. So like I want each one of you to please go through all the questions that have been given. I hope every one of you are going through the question. So this is the last question that we will be discussing at the end. Okay, make sure you all are aware of it, like aware of the questions that have been asked, so that it becomes easier for you to answer them at the end. Okay, so like I'll be ending up with this part now, and I will be continuing with the rest of the part starting from thrust and pressure in the next class. Okay, so we'll be discussing on all of that in the next part, but make sure you keep on revising each and everything that we had discussed so far. Okay, so like I will be starting with that in the next part. Thank you everyone.